from that from the homework? Okay. So today we'll see some of the things that were left out, like modeling of, say, staircases or ramps, okay, or some beams or columns that are at a certain slope with the vertical angle, with the vertical axis. Okay, so I'll begin the presentation now. Okay, so this was the model that we were working on in the previous class, right? So let's see how we can model staircases now. Okay, so I'll open the drawing once. Okay, so let's say we'll be having a staircase over here. Okay, a dog-leg staircase, and the say the staircase will be sorry, computer is yeah, my computer is not responding. Just wait a second. Uh, yeah, so my computer is back now. So okay, let's say we have a staircase in this corner, right? The width of this uh, of the entire staircase of the stairwell will be around, say, 3 meters. Okay, from the central line of this beam. Okay, so say I have a 3 meter width का staircase over here. Okay, so we'll start by modeling that now. So last time I had purposely skipped the reference plane. Right, now we can make use of reference planes for modeling the mid landing region of the staircase. Groups, okay, fine. Groups also we can do. Okay, so say your wait, I'll just turn this up. Okay, so we'll be modeling the staircase over here, right? So we have a floor height of around 3 meters. So we'll be having, say, the staircase will be going up from here. Okay, there will be a mid landing at the mid height of the story, and then we'll be again going up from here to here. So this will continue up to the roof, right? So what we'll do now, we'll make use of reference planes to model the staircase, right? So we have the first story is at 2 meters. Okay, the value of z is 2 meters. So what we'll do, we'll go to edit. We'll go to edit stories and grid systems. Okay. Wait, I'll just unlock the model first. Model is locked. I'll unlock it. Without, if I don't unlock the model, I won't be able to make any new edits. So the model is unlocked. I'll go to edit. Yeah, we can lock it. We can even lock it before. Say our yes, yes, yes. No, yeah, like say if our say we have applied all the loads, we have defined all the load cases and all the design parameters and all have been assigned properly, we can even lock the model so that if other people view, they don't tamper with the model. Okay, so we can lock and unlock it even before the analysis. So okay, now we yes. So we'll go to edit now. Edit stories and grid systems. Okay, we already have a grid system over here that is defined as G1. So we'll go to modify grid system. And now we'll go to reference planes. Right. So our first reference plane will be between story 1 and story 2. Story 1 was at z equals to 2 meters, and story 2 is at z equals to 5 meters. So our reference plane will be at z equals to 3.5 meters, or say depending on the type of the staircase that we have. So we'll add a reference plane, and the z ordinate will be, for my case, 3.5. Okay, and I'll go to okay. I'll refresh the view. Okay. So now what happens is, if I go to this set plan view option over here, hello. Yeah. Okay. You'll see that now a reference plane has been inserted at 3.5 meters. That is between story 1 and story 2. Now, if I select this and press OK, we'll see that reference plane here has been created. Okay, that has the plane intersects the z-axis at 3.5 meters. Okay, so this will now help us to model the staircase. Okay, so before we do the start with the modeling aspect, I'll just go for defining the staircase material, the staircase waste slab material. Material has been defined. I'll define the section. Okay, we had already defined the materials. Okay, we had defined the concrete earlier. I'll go for the section now. So now section properties, I'll go with slab sections. I'll add a new property. Okay, the property name, I'll keep it as says SC for staircase, and the waste slab thickness as say 175 mm, and slab material will be M25, depending on the grade of concrete that we're using. Now, in this case, I'll be using a thin shell, okay, for modeling the staircase. I will not go with the membrane, right? Because there won't be any edge beams for the staircase, so it will not transfer the forces anywhere. If I take it as a membrane, I'll be using a thin shell element over here. the type will be slab, and the thickness will be 175. Okay, so we have defined the staircase waist slab section. Right now, we'll start with the modeling. Okay, now it's again simple. Say now here we have a, we'll be having the mid landing, right? So for the mid landing, I'll be providing a edge beam over here. Okay, beam at the mid height of the story. So I'll go to the plan view, the set plan view, go to reference plane 1, that is at 3.5, and I'll press OK. Right. So now we need a beam over here for supporting the landing, the mid landing. So say I define another beam section over here. All right. Or we can use the main beam that is already there. We can just directly use the main beam that was already defined earlier. We go to property. We'll select the MB 300 by 600 section, and we'll draw a beam over here. Okay. So now what we'll do is the slab will be starting from here, and it will come up till here, say. Right. So we'll be needing the inclined staircase will be, say, having this the width of the landing will be, say, around 1.5 meters. Okay, so the slab will come and terminate here, the inclined slab will terminate here. Okay, and there will be another slab over here, that will be the landing slab, and then another inclined slab will be starting from here and then going up to the next floor. Okay, so I need to remove I need to remove the secondary beam and the slab that was earlier defined in story 2. So I'll just remove them currently, and we have the width of staircase as 3 meters. So just for reference, I'll add some joints over here so that it will help me in my modeling. I'll add some joints here as well. Okay, so I'll go to draw joint objects, and the plan offset will be 3 meters. Okay, so I've created a joint over here. Right, let's make it a little more, say around 4 meters. I think that will be more convenient. 4 meters. Okay, so we have a joint here. Now we'll create another joint in story 2, 4 meters. Okay, and now we'll start the modeling of the staircase. Okay, before that, we'll add another joint here, as the dogleg staircase will be having one flight of stairs going up and another flight of stairs coming down. So we'll add another joint over here at the middle, say 2 meters. So I'll go to draw joint objects. Yes, but yeah, we can do that also. I can just speed it up a little. Okay, so now when we will be drawing this slab over here, we need to make use of draw floor or wall or plan in plan of 3D. We need to use this polygon shaped object at the left. Okay, so we'll select this, and we need to now assign the property over here. The property will be SC175. Okay, SC175. So we'll start like this. Okay, we'll click on one joint over here, and the next joint will be at the reference plane. Okay, say it is somewhere over here. The mid landing ends at somewhere over here. Okay, and then we can go by say 2 meters. You can see that you can see you can see that some dimensions are being shown over here. Okay, so I'll click over here. Then again I'll go down from the move down in list. I'll come back to story 1, and then I'll terminate it here. After the 4 corners of the staircase waste slab is selected, I'll press the right mouse button and the slab will be created, but we won't be able to see it in plan. Okay, so there you go. The staircase slab has been created over here. Okay, now for the mid landing again, we need to go back to reference plane at 3.5 meters. Okay, okay, now you see the while drawing, there are some snap options also that are available to us. We can make use of that, right? Say just before we draw, uh, on the screen we can go for a right click on the mouse button. Okay, and the third last option over here, the snap options, right? You see that just like any CAD software, there are multiple snap options that are available to us. Right, we can go for this line ends and midpoints and perpendicular projections. We can turn them on while working. That will give us an advantage while modeling. Okay, so this half of the mid landing is done. Now the other half, it can be replicated. It can be replicated. Okay, so we'll replicate it. We'll go to edit, replicate. I'll pick 2 points on the model. Yes, we can use mirror also. Okay, now okay, let's explore the mirror a little bit. Okay, so now there is a mirror about line 1, 2. Okay, so we need to define the line segment 1 and 2. We need to define the x1, y1 coordinates and x2 and y2 coordinates. If it's very difficult, we can just use this, pick 2 points on model. All right, and we can just make this the mirror line and press apply. Okay, so this will be created. Okay, now for the last part of the staircase slab, we'll again go to this draw floor or wall in plan elevation 3D, the polygon over here, and we'll again select these 2 joints which are at the reference plane level. Then we'll go up to story 2. This is the other point. This is the other point. And then press the right mouse button. Now to view the staircase, now we can go to the 3D view. You can see that the staircase here has been modeled. But it is to be kept in mind that we will not use the membrane section. We'll be using the thin shell section over here. Okay. Okay. Now assigning loads in this for this staircase is similar to the other slabs that we have seen earlier. Okay, we can just select this this inclined slabs over here, we'll go to assign. We can go to shell loads. From shell loads, we'll go to uniform, the second option, right? So we can apply the, say, the load for the steps as speed loads or whatever it comes out to be. It can be, say, 2 kilonewton per meter square. Okay, now you see that on the screen, some numbers are being displayed. All right, or else we can just right click on any one of the shell objects over here and check on loads and see whether the loads are being applied or not, right? Then similarly, we can apply the live loads. Say live loads, I'll keep as 5 kilonewton over here. Okay, right? We can again cross check by right clicking on the shell objects to see whether the loads have been applied or not. So, okay, now we have created the staircase for one portion of the, only for, say, one floor of the building. Now for the remaining floors, we can use the replicate command directly. But before that, we should insert reference planes at each of these midpoints of the stories, and then we can use the replicate command. Okay, I'll just I have shown the reference plane how it can be used. I'll just now use the replicate command for modeling the staircases everywhere. Now this technique can only be used when the floor heights are equal. Yeah, if we have different floor heights, it's better to use the reference plane method and insert reference planes at the midpoints of each and every story. I have turned on the snap to midpoint option, so we can directly go to the midpoint and check what is the value of z at that location from the right hand bottom corner, and insert reference planes at each and every midpoints for modeling the staircases. Okay. Otherwise, if all the floor heights are constant, we can select the staircase from here, and we can use. There is a shortcut for the replicate command. Okay, we can use Control R, and the replicate tab pops up. We can go to the story command. Sorry, the story tab, and this will be, say, 3 and 4. Right, so we see that the staircases have been created, and we need another staircase over here to the roof. So we'll make use of get previous selection, and you can notice that when the cursor is placed on the command buttons, okay, their respective shortcuts are also denoted. So Control J is for the get previous selection, right? We can use Control J. You'll see that the previous selection gets selected over here. So now we need the staircase at story 5. We'll press apply and see the slabs, the inclined slabs for the staircase have been created. And you see, and for while using the replicate command, the loads and the properties that had been assigned for the main for the initial object that gets repeated in all the other copied objects as well, right? So in replicate, there are some functions, like if you go to the edit, you open the replicate window, okay, and the modify show replicate option for assigns. You can always control what are the factors that you want to replicate, like in case of frames, you've seen that the section properties and all the offsets, insertion points, hinges, and all everything has been turned on. The loads have also been turned on, and similarly, the design overrides also have been turned on. Okay, and for shells also, we have uh, selected all of these options as on. Only the diaphragms have been left out. The reason being the diaphragms have to be assigned at each and every floor. So if the diaphragm gets repeated, there will be an error. So it is always wise to turn this off. All right. Okay. So this is for the links. Okay. All right. I'll close this now. Yeah. 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 Hmm. See, if it is starting from say a floor where there is no beam, there are some there are you can model it in two or three different ways, right? One method is you make that say here in this case, I'll go to say story 4, right? Here this beam is not present, right? So your staircase is directly framing into the floor. Yeah. So in this case, we can either model this slab here as a shell, as a thin shell. Okay. If you model any horizontal floor as a thin shell, your bending property of the shell object gets turned on. Okay. So whatever movements or shears are being generated will get transferred here and even at the junction, right? But you will have to make these joints over here. All right. And another way is you can model a concealed beam. Okay, you can have a concealed beam which will have a say some arbitrary width, and the depth will be of that of the slab. Yeah, it's like a dummy beam. Yes, 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 yes. You can use that as well for modeling that, right? But in that case, what will happen is you won't get the stresses that will be developed over here at this junction. Yes. Yeah. Okay. So your no strut and tie effect has to be modeled separately. Yes, yes, they have to be modeled separately as basings for the columns. Uh, okay, at the base, in fact, you'll have to model them at the base over here. Okay, the relevant properties will have to be created. Okay, by going to say you define. Okay, you define your material properties from there, your modulus of elasticity, and all that from the codal provisions, and your sizes have to be determined of the bracing, right? From the section properties, you define them. You can define them as a frame section and then model. Okay, now I'll show you how like you can model an inclined beam over here, or say an inclined column, right? It is simple. Only thing is you need to work in the 3D view or in the elevation, right? Say I will create some diagonal braces over here. All right, some diagonal braces over here. So what I'll do is this is grid A. So I'll open the elevation for grid A, right? And say we will be defining a brace. Okay, so for the material properties, what you need to do is you need to add a new material. All right, you can go to say other, right? So you have now everything is dependent on the user, whatever we need to, whatever properties for the brace we get, right? So I'm just defining an arbitrary material over here as brace, right? So go to define, yeah. No, I'm not giving any density. Okay, we can give that as well. Okay, I'm just showing how it is to be done. Okay, okay, we can have a add new property. We'll go to concrete, right? We can it's better to have a say a brace. Say the wall thickness is 250. I'll consider that. I'll consider 250 by 250 and have M25. So 250 here, 250 here. Modify show rebar and just keep it like this. Okay. Now we need to draw some braces, say along this bay over here. So I'll go here. I'll go to the draw option. Right. We can do draw beam column objects, and then there is this draw beam or column or brace. Okay. Now what we'll do is we'll select the property for the brace that we have defined. Okay. We can draw it like this. Okay. Or we can have a cross bracing. Sorry. All right. And if the floors are typical, we can also select them, make use of the replicate command. We'll go to story 2 and 1. Sorry, story 3 and 2. Right. And there is another option here for drawing quick braces. Right. So here what happens is if you use this draw braces command over here, uh, quick draw braces command, what happens is like you don't have to moment release them, right? When we draw, you can see that it is already pinned. Okay. Or else there is another option. If you don't want to, if you just want to make them moment released from the go itself, we can always change this over here. From the moment releases, it will be continuous. We can make it pinned. All right. Yes, yes. We can make that for any frame properties. If you want to release them, just so in that case, what will happen is if you open the properties, so you just right click on them. Okay, you can check that the ends have been released. Right. So in that case, what will happen? You'll save some time while modeling. Okay, say secondary beams or something like that. Right. Or even steel structures. Okay. Okay then. Now what we will do is okay. Now for ramps. All right. Say I'll work on this model itself. I'm not. I'll just show how we can make a ramp. Say I'm going to make a ramp from the story 1, right, till from story 1 to story 3. Okay, it'll start from here. Wait, I'll just turn on the pen. Yeah. Okay, so we'll be making a ramp starting from here till, say, here, the penultimate flow. Okay, right? So ramp itself will be similar to that of the, will be quite similar to the staircase, right? We'll be having, say, we just need to define another slab section over here, right? Go to add new property. Say this will be a ramp slab of, I would say 150 thickness. Slab material will be M25. Oh, sorry, this will be 150. Okay, now the modeling type for ramp, it can be done using, say, membrane or a thin shell, depending on the framing that we are having, right? Depending on the framing of the slab, then we can use a membrane, right? Yeah. Okay, we can use shell thin as a standard, right? Uh, so I've defined the ramp section over here. Okay, I'll remove these bases that I've just created. We go to properties, frame sections. The section was BR 25 by 25. Okay, so I say I have a ramp over it that will be starting from story 1 and to the penultimate floor, that is story 4, and the width of the ramp will be 2.5 meters. So what needs to be done over here is, now here what I'll do is I'll make the use of a non property frame element. Okay, I'll yeah, I'll go to the draw. I'll go to the draw command. Okay, the type of line will be frame, and the property will be none. So, say the ramp starts from here and come up still here. Okay, so now this none property is actually uh, a frame that is given uh, as a tool for modeling purpose. Right, we can use this tool for creating intersections, or say even while drawing complicated geometry, or or to even transfer loads from a shell, from one shell to another shell. Okay, it can also be used for the, giving outer plane loads for the shell elements. All right, it has now you can see that this object here has a property of none. So you can check the material properties or the section properties of the none frame section. You can see that it doesn't have any property over here. Okay, this is just a modeling tool. Fine. So now what happens is, after drawing this line over here, Right. Actually, in real-time projects, we'll be having a slope of the ramp, and we'll have to create this line as per the slope. Right. This is just for an example. I've drawn this from here to here. Right. So this point is intersecting this column at this location. So I would need a beam from here, a cantilever beam from here, another cantilever beam from here, another cantilever beam from here, and another beam from here. So now I've selected the columns which this dummy frame, or say this none frame, is intersecting. Right after this selection is done, I'll go to edit. I'll go to edit frames, divide frames. Now, while dividing the frames, I'll use this break at intersections with selected frames and joints. Now you can see in the screen the new frames, how it will be created, right? So now what I'll do is I'll have some cantilever beams over here, okay, and I'll draw the ramp. So now I already have a joint object over here, so I'll use them. I won't draw a new joint. I'll use this, okay. So after the joints have been selected, I'll replicate them. And the dx will be -2, say -2 meters. Okay. So the joints have been created. I'll draw the I'll draw the beams now. Say I'll select this. So the beams will be drawn over here. Okay, now I'll remove the none object. Select, I'll go to properties, frame sections, none. Okay, so now while drawing this, well, now to have the plan view, we can always insert a reference plane at this location for viewing the framing of the ramp, right? We can always insert reference planes at this location. That is, say, z equals to 4.25, then z equals to 6.5, then z equals to 8.75, and this is at the floor level, right? Okay, so now what we'll do is we'll model the ramp slab. Again, we'll select this polygonal shaped slab object over here. We'll select the ramp. Okay, and okay, so this is one part. Another part. Another part. And this is another part. Okay. So we have a ramp. Now, if there is some, say, midline, okay, that can be modeled just the way we had modeled the staircase. Okay. Application of loads will also be the same. We just need to select the slab object. We'll go to assign, and then we'll come to the seventh command over here, shell loads, then uniform, and the load pattern. Whatever loads will be there, we can apply them. We can apply, say, the We can apply the finishing loads, and we can apply the live loads that will be coming. Okay, in the similar fashion. Okay, so this is how a ramp is modeled. Okay, now we'll do some other. There are some other things also, like a basement wall. Okay, how that can be modeled. Yeah. Okay. Yeah, we can always we can have some columns here as well. Okay, we can have some columns here that will be founded, say, at the founding level, and we can have even say some tie beams. Okay, along this direction. Okay, and some along this direction as well. Okay, that can all be modeled just in the same way how we have modeled the building, right? We can even have some. We can even add some grids, right? Say we now a part of this, if there is, say, a revision in the drawing, right? So now your grids are changed, or say this slab, this ramp slab, which was earlier not present, has been included. We need to include them also in the grids now. So what we'll do is we'll go to edit, right? We'll go to edit stories and grid systems, modify grid system, right? Now we were having grid A over there. We'll add another grid. Now this grid will be, say, A dash, and the x coordinate will be -2. Okay, we'll now will if you refresh the window, we can see that this structure here has been included in the grids, right? So we'll check the plan view for any one of the floors. Okay, we can see that grid has come A dash, which is 2 meters from grid A. Right now, we can add columns here as well. Okay, so this is one way of doing this, and we can also edit the grids from the screen. You can see here that lock on screen grid system edit. You turn this off, you can see that you can edit. There's dimension lines, it can be edited, right? Or if you just, yeah. Which one? If you actually just edit that, what will happen is the dimension lines will vanish for all the stories. Okay, okay, right. You can even draw them back. You can go to draw. Okay, you can draw dimension lines, and these dimension lines can actually be used for even dimensioning the model. So you need some dimension, so you can just use it for getting the dimension over here, right? And your this work is complete. You want to delete it, you just do a left click over here and press delete. It'll be gone, right? And again, you need to turn the lock on. Okay, right. Now adding grids can also be done through this. We can draw grids. Okay, say now your grid system is G1. Okay, say this you can have three different types of grids and turn them on or off as per your liking. Okay, so grid system, I have just one grid system now, so I'll draw this grid in G1 itself. Okay, say you had drawn some structure over here. All right, and you want to just draw the grids. So say you have a joint here, you have another joint here. So you do that, you see your grid will come up. Okay, this is part of G1. Okay, you can go to edit. You can go to this edit stories and grid systems. Right, you can add a new grid system over here. Yes, yes. You can have Cartesian, you can have cylindrical also. Okay. Yes, yes, yes. Or if you are modeling, yeah, if you're modeling some curved elements, we can go with cylindrical also. Okay. Okay. Now let's come to this basement wall. Okay, modeling of basement walls. Say I'll model. I'll just. Okay. Now what I'll do is I'll say the say that I want to change the story. I want to change the founding level. Right. That is the height of story one. I'll go to edit. I'll go to the edit stories and the grid systems. Okay, I'll modify story data. Then story one. Story one will be say now 3 meters. Okay, so you see that your structure itself gets modified. Yes, yes, yes. Okay, now what I'll do is I'll just make the I'll say make a basement wall over here only at this location, right? So I'll define a. I need to now basement walls will be modeled as the walls that we have over here. Okay, the wall sections. So we'll go to define section properties. Yeah, bricks. I think, yeah. Okay, bricks. Actually, we don't model them the directly to the thing. Okay. Uh, no, you can. We normally model RCC walls. That can also be done. Okay, if you have the properties, you know, if you have all the. Yeah, yeah. Okay, I'll just keep it simple. Let's just have RCC wall over here. So I say a basement wall. Okay, of say 400 thickness. Right. The grade of concrete will be M25. This will be shell thin. Okay, modeling type will be shell thin, and we'll use 400 thickness. Okay. Now this wall can be modeled either using this polygonal shaped slab object over here. Okay, or we can go to the plan view, go to story one, and draw walls in plan. Okay, the property now will be BW 400. So, okay, and the last one I'll just show using this polygonal shaped slab object over here, how to draw them. We can use this for drawing in 3D as well. We just need to snap the cursor to the four corners of the wall and then right click. Okay, so you can model it in this fashion, right? And now say we need to apply your what is it called? The earth pressures on the wall, or say the water pressure, if there is any. Okay, so we can make use of the non property, the non property, okay, the non frame property as well, for transferring the forces from the frames to the wall. Okay, so what I'll do is I'll just say I'll use the non property. Okay, the moment releases will not matter in this case. Say plan offset will be 1 meter. Okay, sorry, that will be in plan. So what we can do now, say I'll draw another, I'll draw a non-object at the center. Okay, the midpoint snap option is on. So we have a non-object now. And now now I'll draw this non-object at at say 1 meter interval. Okay, along the x-axis, I'll draw it at 1 meter interval so that I can apply the inclined loads for the earth pressure. Okay, so what I'll do is in the ZX plane, yes, that also can be done. Okay, I'll come to that as well. Okay, so what we'll do is we'll go to say replicate. Okay, the x will be 1 meter. Okay, now say I'll create say 10 number of another 10, another, I'll make it as 7. Okay, now from here we go back, I'll make it as 4. Yeah, okay. So now I'll go to the base, make all of them fixed, assign joint restraints. Okay, right, so now what I'll do is I'll apply the earth pressure loads. So before I apply the earth pressure load, I'll just define it as a separate load pattern. I'll go to the load patterns and name it as EP. Type will be dead. Self-weight multiplier will be 0. Okay, so now I'll select all the none objects. So I'll go to properties, frame sections, none. Okay, now I'll assign inclined loads on these frame objects. I'll go to assign frame loads, and the second point, that is distributed. The load pattern name will now be EP, and I that is at a distance of 0 will have the maximum load. So let's just take it as say 30 kilonewton. Okay, 30 kilonewton, and this will be, we need to just define the trapezoidal distribution over here. Okay, now see, this direction of load was selected as gravity, so it has been applied as a gravity load. Okay, so we'll need to get the previous selection. Okay, the direction of load in this case will be y-axis, that is positive y-axis. So we'll go to global y, and the load magnitude will all be positive. Okay, the replace existing loads button is already turned on, so whatever load we apply, that will get replaced. Okay, so you can see now the triangular load distribution has been applied. Now in this cases, the columns here have not received the load, because here we had we had some other section properties. So we'll select them again and give the appropriate load there as well. Okay, right. So actually, the end columns here will receive some lesser loads. Okay, but I have not gone into that. Okay, now what has to be done is we need to divide the divide this wall along all these extra non-property elements that we have drawn here. Okay, if we do not divide the wall, yes, the loads will not be transferred. Okay, so what I'll do is I'll go to plan view, I'll go to story 1. Okay, I'll just select this entire thing. Okay, check the 3D view whether it's properly selected or not. Right, and then I'll go to edit. Oh, sorry. I'll go to edit and edit shells. Okay, and I'll divide the shells now. Now I need to divide the shells at or triangles at intersection with selected frame objects. Okay. Yes, similar to what we have done in frames. Okay, so now what will happen is you can see that these are now separate entities now. Okay, now your loads will get transferred from here to from the frame objects to the wall objects. Okay, so now what I'll do is I'll just I'll run the analysis once, and we can check the moments and the forces being generated at this for this wall, right? So before we just run our analysis, first thing we need to do is to check the model. Okay, we need to check whether there are any overlaps, or whether there are any duplicate joints or not created. Okay, we'll just check it. Yes. Okay, now what we'll do is, sorry, we'll go to the run analysis. Okay, I think there is some error over here. See, there's no proper intersection. Yes. Yeah. So now this thing can be see the slab here has not intersected the frame. So what we'll do is we can use this reshape object cursor over here. Okay. So we'll select this. We'll select the slab that is distorted. Okay. We'll select the joint and push the joint to the frame. Okay, right. And to check whether the frames are properly getting connected, we can always right click on any one of the joints. Okay, and we can check the number of frames that are coming into that joint. Right, we can see that there are 5 frames. So 1, 2, 3, 4, 5 frames, and there is one shell. So there is proper connectivity at this joint. Okay, I'll now again go to analyze. I'll check the load cases that I want to run. I'll say, okay, that's fine. So run now. Okay, we can go to now for the dead load case that we have seen, and there is no displacement over here. We can go to the show deformed shape. You can check for EP. Okay, now you can see that there is some bending over here due to the earth pressure. Right, now to check the bending moments over here, we can always go to this display shell stresses or forces. Right, we can go to earth pressure. We can check M22. Yeah, or M11. Okay, and their values are being shown over here. Uh, yeah, no, for shells it is a little different. I'll come to that later on. Okay, for shells it is a little different. Yes, it is. It is based on that. But for shells, actually, there is one. There's a top face and the bottom face. Okay, so I'll come to that later on. Okay, for normal, say frame elements, it is simple. Like say M33 or say M22. Okay, M33 is the bending, the major bending, and the M22 is the minor axis bending. Yeah, and F11 is the axial force. Okay, yeah. So, but for shells, it is a little different. Okay, there is a top because a shell has a top face and a bottom face. Okay, so that is a little different. I'll come to that later on. All right. So now this is one way to apply the lateral load, or else there is another way we can apply trapezoidal loads on the shell on the say vertical shells. Okay, I'll unlock the model. Okay, and say what I'll do is I'll remove the non-elements from here. Okay, and you can see that frames and shells have been selected. I'll deselect the shells or the walls. I'll go to object type. I'll deselect the walls. Okay, and I'll delete the frames. Okay, now you see that the frames have been deleted. Right, now there is another way to apply the uh, inclined or say trapezoidal loads. Okay, uh, on a wall. Okay, so what I'll do is I'll just select these over here. Okay, I'll go to assign. No, 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 no. We can do it at once. The program will it has its own default discretization for solving. It will do it in that sense. Yeah, yeah. Merge shells is that. We can use that as well. Say I select these. Okay, I'll go to edit now. Sorry, I'll go to edit, edit shells. Okay, and this is merge shells. Okay, but only thing is that two shells can be joined. Okay, say, uh, yeah. Okay, I'll go to shells, merge shells. Okay, but these are horizontal shells, not for walls. Right. Say if I divide floors, I can merge them again. All right, but for walls, it has to be, say drawn again. All right. So now what I'll do is I'll just say I'll delete them. Okay, I'll make another wall over here. I'll make another wall here. Okay. Select this wall. Now I'll go to assign. Okay, I'll go to assign shell loads. Okay, and this will be non-uniform now, but no, not uniform. This will be non-uniform. Okay, now say your direction here will be global Y, load pattern will be EP. Okay, now what will happen is say you have for a non-uniform load, you have this equation over here. Load at point XYZ is equals to AX plus BY plus CZ plus D. This is a in the form of a plane, like an equation of a plane now. So our forces here will not vary along X and Y. It will only vary along Z. So our coefficients A and B will be 0. Okay. And CZ plus D will be equals to the load distribution, CZ plus D. Right. And the load is at Z equals to 0, the load will be 30. Right. So D will be our D will be 30 now. Okay. And at Z equals to 3 meters, the load will be 0. Okay. So this will be minus 10. Okay. We'll apply it. Okay. I'll just now check by right clicking on the shell. Okay. You see that a load has been applied. Right. Now you can actually what will happen is for better results, if you divide it into multiple walls along this line, you'll be getting better results. Or we can just use that we can use the meshing. But your boundary condition will be there only at this point and at this point. Yeah, not in between. So invariably it's always better to mesh it into multiple smaller objects for better refinement of results. Okay, so I'll just analyze it again. Okay, we'll check the deformed shape for EP load case. You can see now how the behavior is changed now. Okay, you can see the behavior of this side, and you can see the behavior of this side. No loads. There are loads here. Loads are here. Okay, but wait. I'll just see the deflections. Okay, wait. You can see the deflections. Okay, you see the deflections are there. Okay, this is a little high. Yeah, this is 0.3. Yeah, yeah. Yes, yes. Okay, you can see here the deflections are less. Yes, it's better to have discretization so that your results are. Yes, yes, yes. Correct, correct. This is just acting like a stretched membrane, held at two ends now. So yes. Okay. Now I'll just unlock the model. Okay. And now you see that I think I've covered most of the things for walls. Okay. Inclined. Yeah, sure. We can have openings. Sure. Okay. Now say I'll just come to this wall that we have here. This is say I'll add one grid here. All right, so that we can have a elevation. This is y equals to, sorry, x equals to 10. So at x equals to 10, I'll have a b dash grid. Okay, I'll go to edit stories, modify, add, and this will be b dash, coordinate will be 10. Okay, so we have b dash here. I'll go to the elevation now, open b dash. Right, so we have now for the lift core, normally what we do is we have a door here for the lift, right? So I'll use that for having the openings. Okay, now I can use the draw rectangular floor or a wall. Okay, I'll select the lift, right, and I'll draw the walls here. Okay, now say I need to create an opening here. Okay, I'll go to edit, right? I'll go to edit shells. Okay, oh sorry, I have to go to draw. Okay, this will be before select, draw, draw floor wall objects, draw wall openings in plan, elevation, or 3D. Okay, now a small window here pops up. Now here what will happen is I need to define the opening, the dimensions of the opening. Okay, now the bottom distance, say we can what we can play with, the width of the opening, the height of the opening. Okay, the bottom distance, that will be the offset from the ground, say the slab level, and the left distance, and the, okay, say, so now I want the opening to start from the bottom, so I'll lock it. You can see that there are lock options over here. Once you finalize the dimensions, you can just block them. The left distance will be say 2 meters. Okay, remind that this is in mm. Right, height will be say 2450, and the width will be another say 1800. Okay, so now you just now your cursor already has the opening. You can check here. Okay, if you just press, yeah, you just press on any one of them, you'll see that an opening will be created. Now this is coming outside, so we can also adjust the opening. We can have it say at 1000 from the left side. Okay, you can see, yeah. Okay, now your openings have been created in the wall. Similarly, we can also create openings in the slab. Okay, say this now, yeah, yeah. Now, only one thing needs to be kept in mind is like once you have drawn the openings in the wall, in the lift wall, we need to select all the shells over here, and we need to divide them for the openings. Okay, we need to go to edit shells. Okay, and here divide walls for openings. Okay, this needs to be done. Okay, for the yeah, for, yes, it will create some discretization. Okay, and your opening will be active now. Similarly, we can also make openings in the plan. Okay, say you have story 2 over here. I want to make an opening over here. Okay, so I'll go to what I can do is I can use this draw floor or wall in plan. Okay, now here the property will be opening. Okay, I can make an arbitrary opening as I wish. Okay, see that the opening has been created. Okay, no, we don't have to discretize for this case. Yeah, yeah. Okay, yes, for wall elements, we need to do that. Okay, I think I have covered these topics in, in detail now. Okay, your inclined wall will be similar to your drawing of ramp. Okay, you just need to have that inclination over there and place the walls. Okay, as per the slope. Okay, using this polygon shape slab element over here. Okay, okay. So now let us. Uh, I'll just give a brief overview. I think I've taken a lot of time for explaining this. All right. I'll just give some. I'll give a brief overview of the response spectrum analysis we did. Then in the next class we can go into detail. Right. Okay. Static. I think we had applied. We had applied the static load. Your loads. I think here it was defined. We had defined the loads. Yeah, load patterns we have defined. We have done this. We have done the mass source. Okay, mass. Yeah, mass source we have applied. Okay, I'll do with the mass source. Okay, I'll start from the mass source. Okay, we'll go to define. Yes, yes, yes. No, your mass source will be required for this also. Okay. Yes, yes. Yeah. Yes, yes. Okay. Now for simplicity, what I'll do is I'll remove this the basement walls that I've created here. I want to make. I want to work on a simpler model. Okay. So what I'll do is I'll just okay, I'll remove the ramps and the staircases. Or what I'll do is just, I'll just turn this up. Yeah. Oh, I think it was saved already. Yeah, we had analyzed it, so it got saved. Okay, then I'll just remove them. Okay. Okay, let's keep the. No, I'll just remove them. They'll create some problems here because we have not defined the. Yeah, yeah. There are no. It doesn't have any supporting beams, so it might create some problems. Okay, let's start with the mass source first. So we'll come to define. Okay, we'll have the mass source over here. Now, in last class we had already created a mass source by the name of ms. Okay, so we'll modify it and check. Okay, normally these two are turned on when you open a new mass source. When you define a new mass source, these two are normally turned on. We need to turn them off, and we'll go to specified load patterns because we already have the self weight in this dead SW. Okay, and whatever say whatever dead loads we have defined will be including them, and the live loads as per the participation factor we'll be using. Okay, and say since I'll be going for the dynamic analysis, I'll keep the include vertical mass uh, loads on. Okay, I'll press OK now. Okay. No. It won't take it at the story level. It will just take it where like the CGs and all are there. Yes. It'll just take it like that. Okay, now next, what we need to do is see, we'll come. I think we have not explored load cases till now. Okay, so we'll come to load cases. Okay, yeah. So load cases, you can see that you are this. There is a dead load. There's a live. Okay, there's modal case, then partition loads, and all these things are there, right? Now see here dead. You can always see what this is by opening the modify showcase option. Okay, you can see here this is a linear static load case of the type dead. What it has is it has the load pattern dead SW, that is the self weight only. Okay, now to reduce this load cases here, we can always have a, we can define a separate load case, say dead, where we can have all the separate dead load cases that are defined here, say partition loads, feed loads. Okay, that we can do. Yeah. Okay, so now uh, we what we will do is here we see we had defined the load patterns earlier. The We had defined the static earthquake load cases. Okay, so that has already been defined as a we had defined load patterns. Now that has already been defined as a load case. Okay, if you just go to modify showcase, you'll see that EQX. Okay, the load pattern EQX is there in EQX load case. So whenever we just define the relevant static load patterns, they automatically get converted to load cases, and when we run them, okay, the program runs the static load case. Okay, so now what we'll do is I'll just okay. Yeah, before we go to delve into response spectrum analysis and the modal analysis, right? One thing we need to do is we need to assign diaphragms. Okay, we need to go as per the codal provisions of IS 1893, right? So we need to have say diaphragms. Okay, so diaphragms here can be assigned by say you can assign the diaphragms to the joints, or we can assign the diaphragms to the shells. Okay, so what happens now? What I'll do is I'll define the diaphragms here. So we have 1, 2, 3, 4, and 5. We have 5 flows here. So 5 levels of diaphragms we'll have to define. So we'll go to the fourth menu here, define, right? We'll go to diaphragms, and D1 is already defined. What we'll do is we'll go to now we'll define D2. We'll define D3. I'm keeping them as rigid currently. Okay, okay, now rigid, semi-rigid thing is semi-rigid is for flexible diaphragms actually. Okay, so that needs to be checked. Like initially, we need to run an analysis, right? Say by having a rigid diaphragm. Okay, we need to check the diaphragm. Yeah, the story drifts and the diaphragm displacements. Okay, as per the codal provisions. Okay, we'll once we run the analysis, we can get them in the form of tables, right? And then we need to check them, and whichever is giving you the worst case results, we need to use that. See, normally, if there are openings in the in the floor slabs, we go with semi-rigid or flexible diaphragm. Okay, so okay, D5. Now what we'll do is we'll come to plan view, right? Story one. Story one here, it doesn't have any slab. So what we can do is we'll just select the joints. All right. Now again, I'll go to assign. Now you go to the joint menu over here. You see there are restraints, springs, diaphragms. Right. I'll select diaphragms now. Now, normally what happens is for joints, diaphragm assignments come from shell object. All right, but in case of story one, I'll keep it as D1. Right, I'll check the 3D view. Now assigning these diaphragms in joints, there is one risk of sometimes selecting a joint which is in some other level. Okay, so this needs to be checked with the utmost care whether there are some joints in some other level or not. Yeah. Okay, in that case, the program will show an error. Okay, no, so we have checked there are no problems as such. Where now we'll go to story two. Right, we'll select here. Okay, now I'll assign the diaphragm to the shell object. So I'll go to assign. Okay, there is this shell. Now I'll be assigning the diaphragm over here. Okay, diaphragm D2. Now you have seen that I've selected, while selecting, I selected all frames and joints as well. But this assignment will be only for the shells. Okay, so again, I'll go to the next row. I'll select the floor slabs, or I'll select everything, and then I'll assign D3. All right, I'll go to the next floor, same exercise, right? And then again D5, same exercise. Okay, you can check now your diaphragms have been assigned, and but without if you don't assign the diaphragms, a lot of the things cannot be checked. That we'll see now. Maybe if not in this class, in tomorrow class. Yeah. Yes, yes, yes. It is the same thing. Okay, so this now your diaphragm has been assigned here. Okay, so after you assign the diaphragm, we'll check the modal analysis. Now, what options are there with us for modal analysis? Yeah, I think that might have been deleted. Okay, I think this this beam here is, yeah, this beam here is missing. So I'll just make it here. Yeah, this column here is missing. I think this column matches with that. Okay. Okay, then I'll go to the modal analysis. Right. So we'll go to the define, and then load case. In load cases, we have the modal analysis option. Okay, by default, it is taken as the eigenvalue. Okay, we have two types of modal analysis with us. We have eigenvalue, we have ridge vector analysis. Okay, so we'll turn the modify showcase option over here. You can see here the load case type or subtype is modal. It is selected as modal, and we have eigen or ridge. Okay, so normally what we do is we'll have this, the maximum number of modes, we'll keep it as, say in this case, as 15. A thumb rule is to have 3 modes for per flow, right? So this is as 15, and you see that the mass source here is taken as MSRC1. Okay, so yes, we defined a different mass source. Yes, that is selected as default, right? So what we can do is we can go to the mass source. Okay, the default mass source here is taken as MSRC1. Okay, we'll make it MS, right? So MSRC1 can be deleted so that there is no confusion. Okay, all right. So again, we'll come back to load cases. Okay, your modal has been defined as eigen now. Now you can see that mass source is MS now. Okay, I'll press OK again. Okay, we'll go to the analysis now, and we'll check the results for the modal, which was earlier turned off. Okay. I think while editing, there was some problems. We had this the secondary beam here, right? And yeah, it was the moments were released, so now it was acting improperly. Okay, we'll check the yeah, we'll check the result. Just just wait a second. I think there's some just while making the model, there was some error. No, it can stay. It won't create problems. Okay, then. Okay. Okay. Now we can check the different mode shapes from show deformed shape, right? There is this mode option now which is activated. Okay, and we'll press OK. And for the start animation, we can see how the mode is how the mode shape is. This is yeah, mode one itself is in torsion, right? And we can check mode two. This is more or less okay, and this is again in a torsional mode shape. Okay, now okay, this is some other periods. Now you'll see that can go to this display button now. Can go to show tables, right? And you see now the analysis results are available with us right now. You can open the structure output, can go to say modal information, right? Now all the modal periods and frequencies, they can be viewed in the form of a table, right? And we have the periods over here, and we have the frequencies, right? We had 15 modes that we had asked the program to give us. Okay, so you can see here that mode 12, 13, 14, they are more or less closely spaced over here, right? Similarly, you can view other tables also. You can add some tables to this. Yeah, we can check yeah, we can check modal participating mass ratios also. Okay, so that table has now been added. We can check here, right? Okay, you can we need to see whether the first three modes, we get mass participation of 65% minimum. So we are getting that. Okay, and you have this along all the three axes. Okay, we have this along the two axes over here. Okay, this is for the third axis, right? And then we have for rotation as well. Okay, so these tables, in fact, can be exported to Excel. Okay, with for say report creation or something like that, right? So we have this, or for even further working on, we can always use these tables. Okay, I'll again go to this display option over here, come to show tables. There are this modal information. We have modal participation factors and all this. Okay, we have center of mass and rigidity now that will be available to us. We have story forces, we have diaphragm forces, we have story stiffness. Okay, all these buttons are now available. All these results are available now. We can check them. Okay, this is the center of mass and rigidity. Okay, we have the center of masses over here. Okay, then we can check story forces. Okay, the forces over here. Yes, these are from the modal analysis. Okay, okay, and even for the earthquake loads also. Yeah, the result is for everything. We can even, yes, we can get the results as per the, say, we go to show tables. Say we need this story forces. We can select the load case or the load patterns. Right. We can say select earthquake Y and earthquake X. Okay. Select the load cases from here. Clear all. Okay. Oh, I think they were. It was not run. I think that was not run. So I'll just check. Yeah. Yeah. Okay. So I think I'll just stop for now. Otherwise, if I just give a lot of information in some small time, it will, people will get jumbled up. All right. So, okay. Any questions from today's session? Okay. Story drifts. Okay. I'll not go in too much of a detail right now. Okay. I'll just show what results and all are available right now with us. Okay. So I'll go to say display. Okay. We have this story response plots available with us right now. Okay, now here the case or the combo selected that's being shown here is dead. We'll go to earthquake. I think that load case is not run. I'll just check once. Yeah, yeah. I think this was not run. So I'll just run them now. Okay. Yeah, that it does. But orthogonal combinations, they need to be separately defined. Yeah, they need to be manually put. Okay, we'll do that tomorrow. Actually, it takes some time. Yeah, and showing that also will take some time. Okay, now I've run the earthquake forces now. Right, I'll run it. The static earthquake forces. Okay, now we can check. Say we'll go to display, show tables. Oh, sorry, I'll go to the response plots. Display response plots. Okay, the case will be now say earthquake X. Okay, and the display type we have say maximum story displacement. Okay, this is yes. No, blue is for your. We have actually global X and Y. Blue is for X direction, means the displacement along the X axis. Yeah. Okay. And this is global Y. Global Y is the uh, displacement of the Y direction. Okay, for earthquake case X. All right. And similarly, we can check for story shears over here. We get the diagrams for the story shears. And if you just take the cursor to this, to these bubbles over here, you can get the we can get the story, you can get the forces, right? That is displayed below. Okay, we have then we have overturning moments. Okay, we have story stiffnesses. Yes, per story, right? And then we have this autolateral loads to diaphragms, autolateral loads to stories. This will show what are the loads being transferred to each story. Okay, then we have diaphragm displacement. Okay, similarly, this is available for all the diaphragms. Yeah, yes. Okay, and then we'll have this diaphragm drifts. Okay, and then we have maximum story displacement. Okay, we can see maximum story drifts and so on. Okay, these things can also be viewed in the form of your tables. Yeah, we can just have you can there is this table option over here, show table. Okay, you can go to formatted. You can see a table. A table comes up here. We can export it to Excel. Okay, so yes. Yes. We can then check the ratios. Okay, whichever is like say whatever maximum permit, whatever limits are there as per the code, whether it's satisfying or not. Okay, so that exercise needs to be done separately. Yeah. So what I'll do is tomorrow I'll have a clean model with me. Okay, I'll have a clean model with me, and we'll work on that. And yes. That also has to be checked. Okay, then defining the response spectrum curves. Okay, which is already predefined, but we need you know, how we'll apply it and all that. Okay, we'll check all that tomorrow, and all the different checks how it is applied. That also we'll see. Yeah, sorry, day after tomorrow. Yeah, yes. Till that time, I think everyone should explore what I've done till now. I think the last 15 minutes it was a little quick. Okay, but but still, yeah, they should, just play with it a little bit, and day after tomorrow, I'll come with a clean model, and we'll see what do you say, clause wise, all the things. Okay, all the all the aspects of IS 1890. Okay, okay. Thank you. Thank you. Yeah. Okay. Thank you. Okay. Bye. Bye.